Hello everyone, welcome to the Equation Web. Today we will be doing another trig problem, so let's start with today's question. So today's question will focus on a lot of topics surrounding exponents and trig, as it is an exponential equation that uses trig. So today's question is 3 to the power sine square x plus 3 to the power cosine square of x is equal to 4. So I'll give you guys some time to find the solution to this equation. Okay, so firstly, through the Pythagorean identity, so sine squared plus cosine squared equals 1, we know that cosine squared is equal to 1 minus sine squared. And we can use that to our advantage and plug that in as cosine squared in our equation right here. So instead of 3 to the power cosine squared, it would be 3 to the power 1 minus sine squared x. So using exponent rules, we can simplify 3 to the 1 minus sine squared of x power to 3 over 3 to the power of the sine squared of x. So our old equation was a little bit cluttered up and it seems kind of hard to comprehend. So we can substitute a variable for 3 to the power sine squared of x. So let's use u for example. So u is equal to 3 to the power sine squared of x, and we will plug that into our old equation. Now, once we plug that in, our equation looks much cleaner. So u plus 3 over u is equal to 4. And we can multiply both sides of this equation by u to get u squared plus 3 is equal to 4u. Now we can simplify this even further by subtracting 4u from both sides and getting u squared minus 4u plus 3 is equal to 0. And this is like factorable quadratic equation, which is really nice for us. So we can find some clean solutions to this equation. And once we factor it, we get u minus 1 times u minus 3 is equal to 0. From here, we get that two of our solutions for u are u is equal to 1 and u is equal to 3. We had an original value for u, so let's plug that back in, and we get 3 to the power sine squared of x is equal to 1. Now we know that anything to the power of 0 is 1. And in this case, we know that 3 to the power 0 is 1, so we can say that sine squared of x is equal to 0. Now we can simplify that even more by taking the square root of both sides. And once we take the square root of both sides, we get that sine x is equal to 0. And if we look at the graph of this equation or just solve it by hand, we get that we have infinitely many solutions, and some of these solutions are 0, pi, 2 pi, 3 pi, and so on. So to represent that, we can use the variable k. And k is any integer. So we can say that our solution set is k times pi. So any integer times pi is a solution for x. Now we can take our second case, which was u is equal to 3. And 3 to the sine square x is equal to 3 is our case. And 3 is just 3 to the power 1. So we can say that sine square x is equal to 1. And now we know that sine squared of x plus cosine squared of x is equal to 1. And if we know that sine squared of x is equal to 1, then we know that cosine squared of x is equal to 0. So we take the square root of both sides of that, and we get that cosine x is just equal to 0. So for that equation, which was cosine x is equal to 0, we get an infinite amount of answers. But some of them were pi over 2 and 3 of pi over 2. And that shows that since there's an infinite amount of answers, we are going to do the same thing that we did before, which was use k, which is any integer. And we can write the solution set as pi over 2 plus k times pi. So pi over 2 plus any integer times pi. Now we had two solution sets, and those were pi over 2 plus k pi and just k pi. And we can combine both of those into one using k pi over 2. That encompasses both of the solution sets in just one solution set. And that gives us the answer to today's question. So today's question was 3 to the power sine squared of x plus 3 to the power cosine squared of x is equal to 4. And the answer to today's question is that x is equal to k times pi over 2, with k being any integer. Thank you for watching, and make sure to like and subscribe.